Okay, thank you everyone for for participating in today's webinar. I will first talk a little bit about our presenter or speaker, Dr. Joseph Burgett, or known as Dr. Drone. He's a tenured faculty in the Construction Science and Management Department at Clemson University. He's teaching undergrad and graduate level classes for the past 13 years. His primary research focus area is applied drone technology, and he used it for bridge inspection and 3D modeling and volumetric surveys and different types of projects. And he published papers about it, and that you can look for it. And today he will be talking about a flight proficiency assessment for state duty unmanned aircraft system pilots or drone pilots. So without wasting more time, Dr. Burgett, floor is yours. You can start your presentation.
Well, good deal. Well, thank you for that introduction, and thank you guys for carving out some time to participate in this webinar. So, as was said, my name is Joe Burgett. I'm in actually we used to be the Construction Science and Management Department, but we've gone through some name changes, and we're officially the Department of Construction Development and Planning. And I always have to take a minute to think about that. So my background is in construction management. You know, in another life, I was a contractor, but as was said, since moving into academia, my primary research focus is in applied drone technology. And what that means is that, you know, I don't build better drones, I don't program software or do computer vision or things that are kind of on the experimental frontier. My field is really taking what's available, what's off the shelf technology, what's off the shelf software, and helping those practitioners, whether they be DOTs or consultants or government agencies or private companies, use available tech to do their jobs better, faster, safer, cheaper. And where a big thrust of my research right now has been on the assessment side. So let me kind of talk through a little bit about what the current rules are, and then I'm going to dive into a little bit about how we're trying to make them a little bit better. So as far as rules go in the United States, drones are governed primarily by the FAA, who at the federal level dictates the rules in which what you can do with and without drones. They can generally be dropped into two buckets, one being commercial rules and the other being recreational rules. Recreational rules are really just for if you're flying a drone for fun, for pure enjoyment. That falls under the hobbyist recreation side, but really anything else falls into the commercial side. So obviously if dollars are being exchanged, that would be commercial applications. But even if you're flying a drone for a friend who might be doing social media posts associated with their business or their, you know, whatever they're trying to do, even if dollars aren't necessarily exchanged, the FAA considers that commercial applications. Unless it's like really pure enjoyment, it's commercial. So those commercial rules are what are collectively called Part 107. It's part of Title 14 CFR Part 107, so abbreviated Part 107. And so what these rules are, and for the most part, they're very common sense and relatively recent. They were only introduced in 2016, so we're in year 6, 7 that they've been out, and they're very common sense. So a few things that I'll just kind of touch on about what they are. In order for you to fly a drone commercially or actually recreationally, you do need to take an FAA test. On the recreational side, it's an online test that's free to take, and you can just go to their website and take it. The commercial side is a little bit more involved, where you have to go to a third-party testing site. It's a $175 exam fee, and then you take a test. More on that here in a second, but let me put a pin in that for now. You do need to stay away, obviously, from manned aircraft. So that's, the FAA does consider drones aircraft, but you got to really be respectful of the skies and where the risks are at. Stay away from manned aircraft. The ceiling is generally 400 feet from the ground or the structure that's on the ground. There are limited flights over people. There are some times where you can fly a drone over top of people, but it's only smaller drones under certain conditions. You can fly at night, but again, there's some restrictions there about anti-collision lighting and things like that. You do need to maintain line of sight, which means that at any point in time, you need to be able to see your drone, know where the front of it is, know what direction it's going, the cardinal direction it's pointing out, all of that sort of thing, which is a big limitation. Maybe not in my world if we're talking about inspecting buildings or whatnot, but if you're talking about first responders or inspecting power lines that stretch hundreds of miles, that's a limitation that they are working on. And then you have to register your drone. So again, it's $5 FAA portal. It's very simple to do. And again, there are a few more rules than this. There are a lot more rules than this, but most of them are common sense and pretty straightforward. Now, at the top of this slide, I mentioned that in order for you to operate a drone, you do need to take a test. Okay. And it is a knowledge test where you go to a testing center and, take a bunch of multiple choice questions about airspace and human attitude and weather and all these different things. But once you pass this test, you are licensed. And this is the only license that I can think of where you can go take a test and be fully licensed to do something that you have actually never practiced before. There is no proficiency component to it. You do not need to demonstrate to be licensed that you know how to operate a small unmanned aircraft system. So that is a limitation. I'm not throwing shade at all at the FAA. There's very good reasons why they released the rules in the format that it's in, but there is an obvious gap. All right. So the way I like to think about proficiency is at the intersection of three components. One is general knowledge, and general knowledge is primarily what is tested on in that knowledge test that you go and again, you spend $175 and get that license. That's general knowledge. Then you need to have what I call field operations. These are skills like when you go out to a field, you to be having the knowledge of knowing how to check airspace. Are you in controlled airspace where you need to request control authorization to air traffic control authorization to navigate the NAS? Or how about crew resource management or risk management, or being able to just understand the scenario that you're in and being able to behave and act appropriately? And then the final sphere is aircraft control. So that's stick control. And that's a big part about what we're working on with some of our work right now. But being able to navigate, use your thumbs to be able to push the drone to a three-dimensional coordinate in the sky. At the intersection of all three of those skills and knowledge is what is flight proficiency. And if you can master those three spheres, that's where you want to be. So let me kind of, again, explore this a little bit with you, is that while in order for you to be licensed by to operate a drone commercially, you do need to take a test, but as I said, it's a knowledge test. The federal government does not issue a license based off your proficiency through the FAA or otherwise. However, the federal government, through the National Institute of Standards and Technology, or NIST, they have created a test, a multi-rotor UAS exam. Now, they just created the exam and they tell you how to score it, but they don't issue a certification or mandate anything. They basically just say, hey, look, we've created this test. Here's how you score it. Public agencies, private agencies, whoever, go forth, use this test in your program, and you say what's passing, you say what minimum is, but here's a credential test. And it has some weight because, again, NIST is a well-known organization. If you've ever heard of the atomic clock, that's NIST. They do tons and tons of things, and again, being a national laboratory under the Department of Commerce, they do lots of things. So there's some credibility associated with it. So let me kind of explain a little bit about how this test works. Just for the sake of argument, so you know what we're doing. I won't spend a lot of time on it, but basically, you're out in the field. You have these apparatuses out here that have these buckets in them. You have a proctor that's standing with you shoulder to shoulder, and the proctor says to the test taker, position your drone here. And then if you position your drone at the right location, you're intended to look down into these targets that are in the bottom of these buckets and take a picture. Now, if you are positioned in the right place, you're not too high or too low, too far to the left, too far to the right, you'll be able to take a picture of this target and be able to see this green ring all the way around. If you can, you're said to be aligned. However, if you're too high or too low, too close, too far away, whatever, the walls of the bucket will obstruct your view to the green ring of the target. If you're out of position, as you are here, the drone's too low, the wall of the bucket is obstructing the green ring. The green ring is broken, and you would not be awarded points for taking that picture. What's nice about it, and I'll mention just real quickly, is that the advantage to this is it's very easy to set up, and the geometry is very simple. All of these targets and apparatuses are 10 feet apart, and you're directed to fly 10 feet high. So if you're 10 feet away, 10 feet up, the Pythagorean theorem, you should be at 45-degree angle with your targets, which is what the targets are at. So again, if you're in the right position, the math is very simple, and it lines up very, very well. Now, while this is a great test, it's been well proven, it's used all over the place. I've administered this test probably, if not thousands, if not hundreds of times, hundreds if not thousands of times. It's a great test. And it works out well, and it works out well for our purposes. But there are some disadvantages of this test. One of the feedback that the FAA got when they initially released the Part 107 rules was this knowledge test was cost prohibitive. It cost, at the time, $125. It's increased to $175, but at that time there was pushback by the drone community by saying, look, that's too much. That's too much money that we're spending on that. Well, they were overruled. I mean, it came out anyway, but that barrier is even more so, and that's one of the reasons there's not a proficiency component to the license now, is that it would be much more, because now, instead of just going to a standardized test site with standardized computers and they're set up for standardized tests, you would then need to have a flight proficiency component. You would need to hire a proctor. You would need to, somebody would need to build these apparatuses. Someone would need to store these apparatuses. Someone would need to set them up periodically, administer the exam, grade the exam, certify the results, all of those things that go along with it, which I don't know what the cost of that would be. It all depends on the scenario and volume and all of that, but likely it would be more than $175. If there's already pushback on that, that's an issue. So good test, but just the nature of proctoring tests creates some barriers and limitations. One of the things that we did look at, and I won't spend a lot of time on this because we did look at it and it turned out it really wasn't that big of a deal. As I mentioned before, and I'm going to use my laser pointer here to illustrate this, but one of the NIST components, or what you are designed to do, is if all of these apparatuses are in units of 10 feet apart, and you're supposed to fly 10 feet tall so that the all the geometry works out. So, like, for example, if you're supposed to be 10 feet away and climb to 10 feet in altitude, well, if you're 10 feet away, 10 feet in altitude, and you're aligned with this bucket, then you should be, this angle here should be 45 degrees or 45 degrees here, and works out well. But what the test, it's a little bit of a limitation, but again, I don't want to spend too much time on it because it really is not a big deal. But what the test is really commanding you to do is maintain a ratio. While this works if you're 10 feet away and 10 feet up and you're perfectly aligned by looking down in that bucket, what happens if you're 20 feet away and 20 feet up, or 50 feet away and 50 feet up? You might be wildly out of position, but if you're up here and your ratio is right, 50 feet away and 50 feet up, you might be wildly out of position, but the ratio is right. You can stare down and you can still see that green ring. Again, that's a limitation with the test. It's an acknowledged one. We did some experimentation with a whole bunch of test takers. It really wasn't a big deal, so I don't want to make it sound like a bigger deal than it is. But it is a limitation to in-person testing. You can kind of proctor it a little bit, but knowing the exact position of a drone by eye is very difficult to do. So what our solution was to this was to put it in a simulator. All right, so it has, by taking those buckets and the dimensions, and there was already software available that had excellent physics for some of the most commonly used drones that were out there. We put it all in the simulator through some industry programming partners. I'm not a computer programmer, but we put it together and we put it in the virtual world. And this eliminated a lot of the barriers that were associated with the in-person testing. It's not expensive. I mean, there was some cost to build it, but once it's built, it's built. And for DOTs, because this software was funded by a FHWA project, all DOTs have access to it at no cost. So there's no cost to build or store the software other than a minuscule amount of hardware space. It's easy to administer the exam because it's part of the software. You don't need a third person, or a second person rather, to observe you taking the test. The computer does it. Consistent environmental conditions, that was a complaint complaint's too strong a word, but a legitimate concern I hear from students when I use this test to assess their flight skills, where their benchmarks against nice, calm, sunny days. Well, what happens if they take their exam when we've got 15 knot winds or something? Is it fair to hold them to the same standard with higher wind conditions or intermittent wind conditions than not? In the simulator, you can standardize environmental conditions, and it auto grades, which is very, very nice. And that S distance issue I told you about, the ratio being where you could be wildly out of position but still be able to see the target. Well, if you can, because this is software, we know exactly where the drone is in the virtual world. We can embed intolerances, which is what we did. If you're out at more than 3 feet away from where you're supposed to be, either horizontally or vertically, even if you can see the target, we don't award points for that. And again, that's something that you can easily do in the software world. As I mentioned, one of the greatest significant advantages of the DOT is because this was funded through stick incentive funds through the Federal Highway Administration. They funded it as part of that agreement. We made concessions that if the software is available to all DOTs at no cost. So it's a great tool to have in the DOT toolkit, even if they don't use it for assessment, but just for training purposes, and even if you're not a big believer in simulation, it's a great way to start. If nothing else, it's a way to get you started, learn some stick control, learn how your thumbs work and how they operate a drone before you invest the time and money and potentially hardware and going out in the field without knowing how to operate it. Now, that's a simulator sounds all great and wonderful, assuming it works, right? And when I say assuming it works, not the software or the programming side where it crashes or doesn't turn on, or is not compatible with Windows or iOS or whatever. What I mean by that is assuming it works, meaning it's a fair comparison to in-person flight. So what we did to evaluate this is we ran a boatload of experiments where we invited people out to Clemson campus. And this picture on the far left, actually the 2 pictures on the far left are at the Y Beach, the Andy, I'm blanking, the outdoor center. I'm blanking on the formal name of it, but the outdoor center that's at Y Beach. This is the soccer fields that are out there. Wonderful facility. Great AstroTurf, flat field, beautiful. So we invited folks out there to take the NIST test in person, and we had grad student volunteers record their time, administer the test, and then we immediately brought them into the lab at the Excel yard, which is nearby. Those of you that are in construction science will be familiar with our lab out there. but we set up computers on big screen TVs, and then we had them take the exact same test, but in the virtual world, and we compared their results. And what we found was they were very, very highly correlated between between the scores and time for how they did out in the real world with the test administered through traditional methods, and then in the virtual world with the simulator with it automatically being graded. So we found that it works, which was a big deal. I mean, it'd be bad if it didn't. So, so the next thing we want to do is when I say NIST test, and again, I don't want to spend too much time on this, but NIST is the lab, and they have developed a series of suites of exams. Now, one of them is called the open test lane. That's what I've been showing you and describing to you. But there are, with that test lane, a test lane is those apparatus that are set up, but there's 5 different maneuvers or 5 different tests that you that you can do to, again, measure your proficiency. So just to kind of illustrate, here is I'll just pick this one for simplification. So for this one here, you fly, you get to an altitude of 10 feet, and then you rotate around these buckets in a clockwise rotation, taking pictures of the buckets as you go around, and then you go back around counterclockwise, taking pictures in at the buckets as you rotate around. That's one set of maneuvers. Here's a set of maneuver where you go up, you fly to the center of this bucket stand over 3 here, and then you rotate around taking pictures this way, then you go over this way taking pictures around this one bucket stands, go back and forth. This one, you go back and forth, back and forth, back and forth, back and forth. So anyways, there's 5 of these maneuvers that are different using the same test lane. And the experimentation that we wanted to do was, do you need to do all these? I mean, if you do all of these, it sounds fine. More data is always better data, but there's a cost associated with it. It takes longer to do it. It takes, instead of maybe a 5-minute test, it's now a half-hour long test. Maybe that's not a big deal if it's one person. If you've got 30 people in the classroom or a training session, a half hour, is a big deal. If you got 30 people, half hour, that's 15 hours. That's 2 days of potential testing. That's a lot, right? So do you need all of that? A little bit I should mention, one of the tests that NIST has really been leaning into, it's using the open lane, but they've been leaning into it. They've done their own experimentation, and they've been pushing this, what they call the BPERP. And I don't mean to throw a lot of acronyms at you, but the BPERP stands for the Basic Proficiency Evaluation for Remote Pilots. I'm going to back up to this slide. It's basically these 2 maneuvers. They took those 2 maneuvers, kind of put them back to back, and said, bam, here's our BPERP. If you can do this test and get a score of 32 out of 40, 80%, and you can complete it within a 10-minute period of time, you pass. All right. And that's all well and good. And that's a good basic proficiency test. It's got the word basic built right into it. So I won't give it too much of a hard time, only to say that it's pretty easy. I would say that, if you're new to droning and you come out with me for a couple hours in the field with the drone, there's a good chance that you could pass the BPERP after 2 hours of experience. Maybe not everybody, but that you're kind of getting the feel for it. So it has value, and it's what the NIST pushed. So there's an inertia on our side to want to use it as well. And we did a bunch of experiments to it as well. So what we did is we kind of go back to this whole idea of like, okay, NIST has this test, or this test lane, this series of apparatuses, and they have these 5 maneuvers, okay? And the experiment question we want to ask is, do we need to do all 5? Or at some point, are we at a statistic level? Can we get by with 1 or 2 or 3, whatever, and be able to say that, look, we are assessing stick skills adequately with not all 5 of the maneuvers, but maybe 1 or 2. So what we did is we ran some statistics to, based off of all 5 of the tests, using that as our dependent variable, and started looking at each of the individual maneuvers as independent variables, and then did a fitness of test, a fitness test to be able to see if how many of these maneuvers, what kind of reliability we could get. And we found basically if you just use a single maneuver, the predictive power with that range anywhere between 0.7399 to 0.9177, depending upon how accurate it was. So pretty good, really. So what we kind of found is you just use one of these maneuvers, whatever you get on that maneuver, you're not going to get a lot more predictive power, how good of a pilot you are, by doing more tests on top of that. However, when you add more independent variables, you get a better predictive power. So we did start using 2 maneuvers, and they range anywhere between 0.9175 and 0.95. So really good. And ultimately, what we ended up kind of going with, and our shop just kind of goes with this, is maneuvers 1 and 2. That's these things over here, because those are the BPERP. That's what NIST is already pushing. It's not necessarily the highest predictive power. We found with our sample that if we were to do it all over again, if we were to use maneuvers 3 and 5, the predictive power will be a little bit better with our sample. But all in all, there's something that's already out there that's working. NIST is already pushing the BPERP. It's pretty close anyway. We're not going to upset the apple cart. So we stick with the NIST, and are moving forward with that. So again, this is where we're focusing on right now, okay, is aircraft control. You got these 3 different fields that define flight proficiency. General knowledge, that's the part 107. Aircraft control, that's your thumbs. That's what we're doing with the simulator. And then field operations, I'll get to in a little bit. But right now for aircraft control, based off of our sample, we kind of came up with our own evaluation based off of our samples, and we did it by percentiles, based off largely of people that took my class. Really, those were the folks that had 10 to 16 hours worth of flight experience, how well they did. So based off of our sample, we found that if they could complete that BPERP test with a perfect score in 5 minutes, you were in the top 10% category. That was an A grade. If you were able to complete that BPERP in 6 minutes with a perfect score, you were in the top 20 percentile. That was a B grade. And then of course 7 minutes, C grade, 8 minutes, D grade, and then 10 minutes is what the BPERP is. So again, it's fairly easy. What we found really was the scores were not a good discriminator against proficiency, because you can, if you're going to get the test, if you're going to get it right. Can you see the green ring or not? I mean, so if you can't see it, then you're still going to fly around until you can see the green ring and then take the picture. So really, the points weren't really the discriminators, how quickly you could line them up. So time was more of a factor. So that's what we've kind of found. So where are we going with this? Okay, so we brought a boatload of students and volunteers through Clemson to kind of develop our scoring metrics, but that's all well and good, and that works well for the classroom, especially for our purposes at Clemson. But what about DOTs? We wanted to develop a scoring proficiency for the DOTs of the world and say, okay, what is good enough? What is a quote unquote A grade for the DOTs? Well, I don't know. I mean, I can't, I can guess and I can probably get close, but I can't say, look, SCDOT or Texas DOT or California or Utah or Minnesota or whatever, this, by God, this is what your pilots need to be at. I can't say that. But what I can do is I can go around the DOTs. I can have them take the simulator test in our presence, and this is a PhD student that's working on this with me, and take the BPERP in our presence, observe their scores, and then record them. And while I can't say, hey, look, for you to fly a drone at the DOT, you got to get this score, but what I can do is say, look, this is the pilots that are out there now. This is what they're getting. So this is baseline. These are the current pilots that are flying these drones for DOTs. Here's how good they are. we can argue about if they should be better or worse, but let's baseline what they are now, and then have that discussion where they need to be better or worse. But at least we can benchmark where we're at, and that's what we're doing right now. Colin Dees, some of you guys may know him. Is making phone calls and calling DOT pilots and scheduling these Zoom interviews where he asks them some questions about, what kind of missions they're flying, and then observes them flying the BPERP and records their scores, so that we can get that baseline. Here's how good DOT pilots are now, and then use that to benchmark some proficiency. Then, okay, so moving on to the field operations. So fortunately, we've got some help with the field ops. So again, these are things like crew resource management, risk management, physical skills that go along with flying with the mission, not necessarily just the thumbs. And fortunately, there's some help from ASTM F3266 that has identified specific categories and tasks that you need to be proficient at, as well as provided benchmarks for how good they need to be, level of competency, competent, sufficient. They have nomenclature for how they have to be at things like, again, crew resource management, aircraft inspection, risk management, situational awareness, telemetry data on specific aircraft, all of these things that you should be able to do outside of moving your thumbs to be proficient at operating a drone. So fortunately, we got some ASTM standards, and we are going to use that. While this standard tells us what they need to be good at, there is no exam out there that tests it. So that's what we're generating right now. That is a study that C2M2 is funding right now, for us to use both the data that we're collecting from drone pilots using the NIST test for the stick component, that one bubble, and then the ASTM standard that's already identified the flight proficiency areas that need to be tested on where there is no test. We're going to combine those into a singular comprehensive assessment that we are then going to pilot test out with SCDOT employees. So part of this project is a training program that we're providing through Clemson online and an in-person boot camp. Then we're going to give them this flight proficiency assessment that deals with those two spheres of overlapping to flight proficiency. We'll see how they do. We'll see areas that need to be improved, where the training might not have been up to snuff, or just the questions were confusing or whatever, and then generate this assessment that we can share with other DOTs for them to incorporate into their system. What we're seeing really right now is if you're at another DOT, again, every DOT is different, they're state by state, but most of them have a group of drone pilots that are not full-time drone pilots. They are part-time, they have another job, but they use drones to support them. But there's a drone lead, and that drone lead will go to the drone pilot and say, look, okay, you want to be a drone pilot? Okay, first thing, pass your Part 107. They pass their Part 107. Then they say, okay, let's go fly around a little bit. And they go through and just kind of do a flight, I'm blanking on the term for it, what they use for manned aviation, but a check ride, where they go out and they just fly around a little bit and check through a few things, and it's kind of more of a subjective, yeah, I think you know what you're doing, you're good, and then you're issued a drone on your way. We're looking to take the subjectivity out of that and give them an assessment that, look, if you can pass this test, then you have the necessary skills and knowledge to fly a drone. Again, it's not subjective, it's data driven. So we'll hope to share that with other DOTs, and it'll complement the Part 107 exam. It'll have stick skill scores that are data driven by existing pilots and where they're at, and then a fully pilot tested exam that's been tested out through SCDOT, and hopefully the bugs worked out of it. So with that being said, everybody, that's what we're working on over here. So any questions that I can address for you guys, feel free to turn on your mic. There's not that many folks on the call, or if you're more comfortable just typing them in the chat, I'm happy to read them that way too. So any questions I can answer for you?
First of all, thank you, Dr. Burgett, for the presentation. I have one small question. Is like the simulator, you said it's available for DOTs for free, but how about the other companies? Can they get it for free or
Yep,
something?
not for free. I mean, so the partner that we worked with is a for-profit private company. So the deal that we was struck with them was we had a discounted development rate in order to develop these modules, and so it's free for DOT because again, DOT's paid for it. But the flip side of that is now that's an asset that they're able to sell to private companies. So if other agencies or government agencies, private companies, schools want to use it, they're welcome to it. But again, it's not for free.
Thank you.
And if there are anybody from a DOT that would like to get this, feel free to email me. My contact information is on the screen. Send it to me, and I'm kind of the gatekeeper for getting you access, but I'm happy to do that. Just again, send me a note. Or if you just want to know how to get it, if you Google Zephyr, like the blimp, a Zephyr flight sim, you'll be able to get to their website, or just send me an email. I can direct you to it.
Hi, Joe. Nice presentation. So I just wanted to ask you, so one thing is the aircraft difference, and then the other thing is, I know you mentioned the number of hours of experience, but the time component is still be there, like in terms of like you had the check ride, if how that could be incorporated as somebody having 100 hours and then getting that test would be a little bit different than somebody, who'd like to get that. But there will be some learning curve, I guess.
Yeah. So your point is really well taken, and a lot of the DOTs, again, as we're kind of calling around and having them doing the simulator, the first part of that is an interview where we kind of talk to them and interview, and what we are seeing is that there's huge differences in terms of how much flight hours that pilots are required to have. I was on the phone with South Dakota yesterday, actually about 24 hours ago from right now. They require 2 hours to be issued a drone. They go out with a flight instructor and they train for about 2 hours. And as long as they can kind of do the basic skills, they're issued a drone to do basic missions. Other places, for example, Texas, they have a much more robust program where if you want to be a pilot, you go to a week-long 40-hour boot camp and you fly with a group of people, a lot of one-on-one instruction. Then you are issued a drone, and then you're required to do another 40 hours on your own. So huge discrepancies and differences of opinion about how many flight hours should be there. I don't know that I have the right answer for what it should be. There's going to be a little subjectivity in that, and that's it's a good question. It's beyond the scope of what I'm going to be able to answer. I'm going to guess. I'm going to put something in there that I think is reasonable, but Gurjan, that's a really good point to make, that it needs to be in the test. But it's going to be a little bit of a subjective matter about what's the number that is required. Does that make sense? That answer your question?
Yes, Joe. Thank you very much. How about the aircraft differences?
So the simulator that we did, it's got, I want to say 14 different commercial drones. So when we did the experiment that we did, there was really 2 that we oscillated with. You may not know these. One is a Mavic. It's hard to describe. They're Mavic, and the other one's a Phantom. The Phantom's like a white quadcopter. In any case, those were the 2 that we used because those were the physical drones that I owned. So we use those in the field, and if you use a Mavic in the field, then you were required to use a Mavic in the sim. If you use a Phantom in the field, you use a Phantom in the sim. in all candor, between those two, I can't even tell the difference between the physics. The other ones, the bigger drones, you definitely can, and there are differences in them, but we limited it to those two smaller drones. It probably is a good exercise. To a more expansive study would have been to incorporate other drones into it to see if there is any discrepancy, but we don't own all those drones, so it's kind of a limitation of what we could do.
Sure. Thank you, Joe.
Yeah, great questions. Thank you.
Is there any other questions from the audience? Rick, do you have any question? Maybe you can ask about your project.
Yes, sir. So, sorry for joining late. I just saw the data was for the pilot training, right? Hello?
Yeah. Yes. Yeah. Yep.
Yeah. So, my question is, apart from the pilot, if we are including sensors, like, is there any way to track how the sensors are performing? Because the dynamic nature of the drones enable us to use sensors in them, but whether it's performing well during the dynamic nature versus it's kept static and then measuring. So, is there any way to measure that?
Okay. Well, you're touching on a really good point. And let me elaborate a little bit. So there is a little bit of a discussion in our world about do stick skills matter? Because as this technology progresses, in fact, we're really already there. If you're familiar with a Skydio drone is a fully autonomous drone that, as it flies, it creates a real-time point cloud, and it navigates based off of the point cloud, which is actually how human beings navigate. If you look around your world, right, you close your eyes, you have a mental image of the room that you're in. And if you, even with your eyes closed, I could find that door behind me. So I created in my brain a real-time point cloud, real-time mental model of my environment. Well, that's what Skydio drones do, is as they fly, they have sensors around them and they create their environment and they navigate through it. By doing that, they are able to go into bridges, fly through trusses, up and down, and get very, very close without any interaction for the pilot. I mean, literally, the operator goes to the drone and says, look, I want to map this bridge. And then the drone goes and it does a high level scan of the bridge, kind of gets the overall dimensions of it, and then creates a waypoint mission and flies all the way through it. In that scenario, very complex flight, really minimal, if no, interaction from the pilot. So it begs the question, do you need any kind of stick control? I mean, if you're using a Skydio, wouldn't you, an argument could be made that you can be proficient without really knowing how to fly at all? And I would push back on that argument, and I would say, your point is taken, but what happens when something goes wrong? What happens when your drone is in the middle of a bridge and it gets confused or something goes out and you need to get it out of there? So even then, I'm going to push back and say that you still need to have stick control. So that is a debate, and I think Rick, Rick's iPhone, I hope it's Rick that asked that question. So that's part of the issue. But your question specifically was about measuring the accuracy of the sensors. It's a good question. We didn't address it. Every drone's got different sensors, and they have different limitations and strengths and advantages and all, and layout and all those type of things. Some are better than others, right? And some are more accurate than others, and some make it easier to fly and others, and all of that is true. Some of them make it a lot easier to fly. So it's an important piece. We're not addressing it because, again, every drone's different, every model is different, and then as soon as we do that study, they're going to come up with new models. So We're not focusing on that. We're focusing on basic thumb control, and then to know how to make sure if you want to go forward, you use your right hand and not your left hand. And then also the other stuff that goes along with it about situational awareness, crew resource management, risk management, all of those things that are independent of the type of drone that you're flying. So really good question. I'm going to summarize it this way. Really good question. It's somewhat beyond what we're doing, but that's not to say that it's not important or relevant or an important piece of the discussion. So thank you. That kind of answer your question, sort of?
Yes, sir. Thank you.
Yeah, great question. Thank you for raising it. Any other questions?
Yeah, do we have other questions?
Okay, well, hearing none, I do want to just thank everybody for attending, and I have my contact information. If there is anything that I can do to help, please reach out. Shameless plug: if there's any Clemson University graduate students, I do have a drone class next semester. So if you are interested, please take a look at CSM 8690. It's a great class. So I'll leave with that. So
Yeah. Thank you very much,
Thanks.
Dr. Burgett, for your presentation. Yeah, and on the side, I really look forward for the results of your project because I took your class that you just talked about it, and in some of it was very difficult to get A in some assignments. Like for me, like if you were like flying slow, then like for accuracy, then the time would have you would take longer, but if you go fast, then the accuracy would have been gone. So that's what I am looking like. Well, let's see what duty people, those people who are already in professionals, what they do, and see like maybe we can change some of the scoring criteria or something. But
make it easier.
Thank you very much for your presentation.
Absolutely. Well, thanks for inviting me.
Yeah. Okay, I guess that's all, and thank you everyone for participating, and look forward to the next presentation, inshallah.
Thank you, sir.
Very good.
Bye-bye.
Thank you.
Thank you.